When you're exporting a floor from MezQuote into AutoCAD, you need to have a little think about the insertion point for the floor, because obviously, ideally, we want the floor to come straight in to the correct position on our layout. MezQuote uses the bottom left-hand corner, or the column actually, as the insertion point when it gets inserted into the AutoCAD drawing. So what we have to do, and it actually inserts it, by the way, at 0, 0 in the AutoCAD model. So what we have to do is just make sure that our plan, our layout, the bottom left-hand corner, which I've shown with a circle around it here, we need to make sure that that point is actually 0, 0 in our CAD model. So what we do is we just move the whole lot. We're just going to move everything, pick up the base point as the center of that circle, which is there, and move that to just type 0, 0, 0, and it will move the whole. If we just zoom out a little bit, somewhere we'll find, there's our outline. And we can double check. If you type ID, it will give the ID of the point, and that should be 0. There we go. So we know that we're definitely correct, so everything's going to be on the same datum point. Okay, so I've gone into my CAD. We've created our file. I'm going to go to Import Link File. I'm just going to bring this menu into focus a little bit. Okay, the second command in, Import Link File, so we'll just go to this page. We're set to import. We're importing MezQuote. We just want to make sure that cutbacks are included because we want to cut back our joists and our columns and so on. I'm just going to go to the correct folder, and in there is our file that we created. So I'm just going to go open. There we go. And I'll go open, and then all you do is just click OK, and you'll see things start to happen. Basically, it will insert our mezzanine onto our layout. And what it's doing now is just putting our connections on there. Remember, we offset our column by 400. It knows that, so it's going to put the column in the correct position on our layout. Okay, and now I can get rid of that circle because I don't need it anymore. So what we have is our floor. These cyan coloured lines, they're our main beams, and the joists obviously are spanning between them. Up here on our toolbar, we'll just go to Show 3D. What that does is it converts the stick into a 3D view of the floor, and basically if I go to Show Labels, it will show that that has been imported as beam B1. Let's do the same on the next one. In fact, I'll convert all of my beams. I'll do those. But I mentioned earlier, right at the beginning, about this toolbar up here. This allows you to isolate different types of member within the drawing. So if I switch off my layers and then just switch my beams on, I can see all my beams and I can just do them all in one go. Okay, so it's now done that, and then I'll just label them all. So you don't have to go around and pick everything, is the point I'm trying to make. By manipulating the layers, you can save yourself an awful lot of time. So switch everything back on again, and all my beams are now marked. It numbers the beams sequentially, B1, B2, B3, right through to the end. You can modify those mark numbers if you want to, but there isn't really a big reason to want to do that. Let's just show the mark numbers on my joists. So those are J1s, and these will be J2s. So normally we just mark one or two of them on the layout like that. We also want to show our columns quick tip that I always suggest is to use the 3D viewer when you want to select columns. This is a 3D viewer. It'll either look at the plan or an isometric view, or you can look at a front elevation. Basically what that allows me to do is say show 3D on my columns and then just put a crossing window right the way through. You can see our bracing members there as well. What I want to do is mark those as well, so I'll show my mark labels. It's just easier to select them that way. And we just go back to plan view when it's finished. Go back to plan. So all my columns are marked. Column marking usually requires a little bit of alteration. We have a default system for column marking, but we can modify them. For example, all the columns in this run along the top here are actually the same, but our default marking puts these as C4s. So to change a mark, you just go to MultiSTEEL. You can just click on the label, change them to C3. So I'm going to override my default marking. So that's great. See here how the column is actually inserted correctly into our drawing there. Okay. The point I want to stress, if we go to an isometric view, is that when MultiSTEEL imports a column, let's just look at one of these columns here. Maybe that one's a good example. I'm just going to switch off my layer where my original columns were drawn. What we're going to do in a minute is just extend this beam so it comes to the end of the cat plate. But what it's done is trimmed the column and allowed a gap for the cat plate and the base plate. So that column is now a completely accurate and a ready for fabrication sort of member. We can check the column. If you go to query, we can do a query on the column, and there's our gaps. So we're using a 10mm top and base plate, and we've got a cut back to allow for the depth of the beam. And we can see the total length, the cut length is 2833. Now MultiSTEEL does all of that work when you import the drawing, so it's less work to do when you come to do your fabrication drawings. Typically when we edit a beam, we convert it to a stick, so we say show stick, click on the beam, click on its grip point, switch ortho on, and I'm going to extend it by 100 millimeters. Okay, whilst the grips are still live, you can just go back to show 3D. So what I've done there is I've extended my beam just by changing it to a stick and then just using normal AutoCAD editing, which is the beauty of the system really. You can just treat it like any AutoCAD drawing, even though it's intelligent steel. Okay, so let me just go back to plan view. What we'll do is in the next video we'll actually look at some more small modifications to the drawing, create some material lists, and start to think about the actual fabrication drawings.